All right, let's get right into it. We're going to talk about one of the most chaotic, widespread, and honestly, one of the longest outages in the history of the modern internet. A day when a huge slice of the digital world just went dark. And I'm not exaggerating here. This thing was colossal. For pretty much an entire business day, tech teams were split into two groups. You had one half in an absolute all hands on deck fightering mode, desperately trying to fix systems that had just vanished. And the other half? Well, they just got to sit back, because with the cloud down, there was literally no work they could even do. It was that big. From 11:48 p.m. on October 19th all the way to 2:20 p.m. the next day, a full 14 and a half hours. You know, in internet time, that's basically a decade. So the big question is, what in the world could bring the biggest cloud provider on the planet to its knees for that long? I mean, you'd think it would have to be something huge, right? A solar flare? Some massive cyber attack? A physical disaster at a data center? Nope. The real answer is so much smaller. And, that almost makes it more terrifying. It wasn't some big external force, it was a bug. A tiny, almost textbook coding error that kicked off the most catastrophic chain reaction you can imagine. So to really understand what happened here, you have to see how this one tiny failure just cascaded through the entire system. It was like watching dominoes fall, toppling one critical service after another.
Okay, so it all kicks off just before midnight. The core database service DynamoDB basically disappears from the internet. Now, within about 3 hours, the engineers actually fixed that initial bug, but the damage was already done. The system was flooded. By 2:25 a.m., the service that manages all the virtual servers, DWFM, gets hit by this tidal wave of backed up requests, and it just gives up. It crashes. Then, by 5:28 a.m., once DWFM is back online, the network manager is the next domino to fall, totally overwhelmed by all the servers trying to restart at once. It took another 5 hours just to clear that backlog. And finally, at 2:20 in the afternoon, the last of the services flicker back to life. A 14-hour nightmare from start to finish.
So let's zoom in on that initial spark. What's so wild is just how simple and, well, classic it was. The culprit wasn't some super complex, sophisticated flaw. It was a good old-fashioned coding error.
It's something called a race condition. It's a programmer's nightmare, really. Put simply, it's what happens when two different processes try to mess with the same piece of information at the exact same time, and the timing gets all messed up, leading to a result you never ever wanted. In this case, a catastrophic one. Okay, here's how it went down. Picture two little robot writers, process A and process B. They're both trying to update the same address in an address book. So process A gets a new address, but for some reason, it gets stuck. It's delayed. While it's stuck, process B comes along with an even newer address and writes it in. Perfect. But then, process A's delay is over, and it finally writes its old address, completely overwriting the correct one. Now here's the kicker. Process B has a cleanup rule that says, delete any address older than mine. It sees the old data that A just wrote, and thinking it's doing the right thing, deletes it. The result? The address entry is now totally blank. And that's exactly what happened to DynamoDB. Its address on the internet was just wiped clean. But here's the thing. A single bug, even nasty one like that, should never be able to take down the whole system. The real problem wasn't just the code. It was the entire architecture that let this failure spread like a virus. This quote just nails it. To move fast and innovate, all the teams inside AWS build their new services on top of the ones that already exist. So you have the server team depending on the database team, who depends on the network team, and so on. It's super efficient for building things, but it means everything is tangled together. It's all tied to one string, and if that one string breaks, the whole thing can just completely unravel. And this really gets at a key difference in how these massive cloud providers tend to fail. When you look at outages on Microsoft's Azure, they're often simpler, more isolated things, a bad configuration change, maybe a denial of service attack. But AWS outages historically are these deeply complex cascading failures. A core service, like the database or the storage system, gets sick and takes hundreds of other services down with it. And if you follow this stuff, you might notice a pattern. These huge outages often seem to start in one specific place, US East 1. So why there? Well, it's the oldest region, it's the biggest, and for years it was the default choice for tons of companies. It's where all the new features get launched first. The result is this massive concentration of risk. It's like the entire internet decided to build its capital city right on top of the San Andreas Fault. Everyone is just huddled together, living and dying together. So this brings us from a purely technical problem to a much, much messier business problem. If these outages are so painful, and we kind of know why they happen, why don't companies just build their systems to survive this stuff? I mean, the technology is there. We have well-established ways to do multi-zone, multi-region, even multi-cloud deployments. So why isn't everybody doing it? Well, the answer, like it often is, comes down to money. Building this level of resilience is incredibly expensive. Just running your system in multiple data centers in the same region, that can double your cost. Want to run across multiple different regions, like coast to coast? You're looking at maybe 4 times the cost. And going multi-cloud, running on both AWS and Azure, that could be an 8-fold increase in your operating expense. It's a huge price tag. So put yourself in the CEO's shoes for a second. You have a choice. You can spend a massive, guaranteed amount of money, maybe 8 times your current cloud bill, to protect yourself from a black swan event that might happen once every few years. It's a really tough trade-off, a huge, definite cost versus a rare, unpredictable benefit. And for most, the math just doesn't work out. They accept the risk. And there's a really strange kind of logic at play here. The worst thing for a business isn't just having an outage. It's having an outage alone. If a giant AWS outage takes down your company and all of your competitors, who gets the blame? AWS does. You're just one of the victims. In fact, the few companies like Netflix that actually built multi-region systems and stayed online during this outage got almost no praise for it. There's a weird, perverse safety in numbers. And really, this all boils down to a fundamental conflict. It's the ideals of technology clashing with the hard, messy constraints of reality. As engineers, as tech people, it is so easy to get mad at these decisions. We see the messy code, the fragile systems, and we just want to build something perfect and resilient. But this point here is so important. These might not be the most scientifically sound decisions, but they are often the most realistic business decisions. Technology doesn't exist in a vacuum. It's a tool, and it's there to serve a purpose in the real world, which has real budgets and real trade-offs. Which leaves us all with a pretty critical question to think about. As our entire world becomes more and more dependent on these massive tangled systems, we have to decide what level of risk we're okay with. What's the right price to pay for being safe? And maybe more importantly, who gets to make that choice?